This is a pre-built version of the application. So if I go ahead and run it, now suppose a company's hiring decisions are based on two interviews, and suppose that we have legacy data that shows who was hired based on those two interviews, and the score for each interview is on a scale of 0 to 10. And this is the score for candidate interview number 1, and this is a score for candidate interview number 2. And logistic regression with gradient descent was implemented here, and we discovered those weights and this equation of the decision boundary. And the candidates to this side of the decision boundary were not hired, and those to this side were hired, and those two candidates were misclassified. Next, let's go ahead and classify some new candidates and predict based on their interview scores if they will be hired. So this is the score for this candidate on the first interview, and this is the score on the second interview. And this is the probability that this candidate will be hired, and the candidate was classified as 0, which means that he will not be hired. And those are the scores for another candidate, and this is the probability that this candidate will be hired, and he was classified as 1, which means that he will be hired. I will start by creating a new project, and here we need the full JDK since we will be using JavaFX. And this class will have the logistic regression logic, and this will be the application driver class. So it will have a main method, and it will extend from application since we are using JavaFX. And we will be doing matrix operations. So I'll pick up the matrix class from this project. Now this is the training data that we will be using here. So this is the bias, it's always 1, and this is the result for interview number 1, and this is for interview number 2, this column. And this is the label column. So 0 indicates that that candidate was not hired, and 1 indicates that he was hired. And we will have two-dimensional arrays. So this one will contain the bias and the two scores for each one of the candidates, and this one will contain the labels. and we populate them here and then turn them into matrices. And we will be using those two matrices here. Let's return null for now. Now this is the definition of the logistic regression hypothesis, and G is the logistic or sigmoid function, and this is that function. G of z is equal 1 over 1 plus e to the minus z, and the gradient of the cost function, this is the definition of it, and we update the weights using gradient descent using this formula. So this is the gradient that we defined here, and this is alpha, which is step size. So if we plug in the gradient here, we end up with this equation. Now before finishing up this method, we need to go to the matrix class and add two methods that we will need. So this one applies exponential to all elements of the matrix, and this one does 1 over all elements of the matrix. And let's go up here and make this one public. And if we go back to this class and define this method, so the sigmoid method, so e to the minus a number is like 1 over e to that number. So WS, this matrix, exponential of 1 over, so we're saying e to the minus that matrix, and we're adding 1 to it, and then doing 1 over that addition. And now let's define alpha, and we'll set it to this number for the purpose of this tutorial, and the max number of iterations is the number of times to repeat the gradient descent calculation before finally stopping. And this is the code that does gradient descent. So we will be returning a weight matrix. So we start by creating a two-dimensional weight array and initializing it to 1 everywhere, and then turning it into a matrix. And here we apply this formula. So the hypothesis and the sigmoid function gave us this. So G of W transpose X will be the probability. So it will be equal to 1 over 1 plus e to the minus W0 plus W1x. So for our example, suppose we only have one interview instead of 2. So this this is W transpose X, and this is G of W transpose X, and we're between 0 and 1, and Y here is the label. So if G of W transpose X is bigger than 0.5, then Y is 1, which means the candidate was hired, and he was not hired otherwise if it is smaller than 0.5. And if W transpose X is smaller than 0, we predict that Y is 0, so the candidate was not hired. And if W transpose X is bigger or equal to 0, then Y is 1, so the candidate was hired. And this is the implementation of the classification method. So we pass it the candidate scores, this matrix containing them, and the weight in this other matrix, and we apply the sigmoid function and get the probability, and if it is smaller or equal to 0.5, then we predict that the candidate will not be hired, and otherwise we predict that the candidate will be hired. So this should do it for this class. Next, if we go to the driver class, and here this will be the logistic regression instance that we will be using, and this is the weight matrix, and those M and B are for the line decision boundary, and this is for the weight display purposes. So going here, now we can call the logistic regression gradient descent method, and pick up the weights, and based on those weights calculate M and B for the line, and put that weight information in this string buffer, and then call launch, which would trigger a call to the start method. And let's define this static handle command method, which is used for classifying new candidates. So it calls the classify method on the logistic regression, and print out the string that is returned. And this is JavaFX display code. Next, let's go ahead and test run the application. So this is the decision boundary that we discovered. This is the equation of that line, and those are the weights that we discovered, and the candidates here were not hired, and here they were hired, and those two candidates were misclassified, and let's try to classify a new candidate that have those two scores of the two interviews. So the probability that this candidate will be hired is this number, which means that he was classified as 1. So prediction that he will be hired. Let's try another candidate with this scores. So this is the probability that this candidate will be hired, and he was classified as 0, which means prediction that he will not be hired.